there. Okay, so that's what it looks like once I've got all of that ooky stuff off the eyepiece camera and the lens. And that was the condenser that I'm dropping down. So let's focus on the slide. Oops, something just went swimming there. Okay, that's probably a very small ciliate right there. Oh, okay, there's some bigger ones. In fact, it looks like a whole bunch of them, and it looks like they are glommed together on something that they might be feeding on. So let's zoom in right there and see if we can see those guys a little better. Yeah, this is cool. A bunch of little brown ciliates. If they're moving really fast, there's not a whole lot you can do. In the lab, we could add something like nickel chloride to paralyze them, but unfortunately, we can't really do that on remote. Okay, and I've still got some of that schmutz on my lens. But there we've got, these are a bunch of ciliates. There's lots of them here. You can see there's also either bacteria or microflagellate eukaryotes swarming around. And in this case, I'm not entirely sure what they are. If you look very closely, it looks to me that maybe 3/3 of the way towards one of the ends, there's a little dent, a little indentation. That's probably the site of the cytostome and maybe the peristome as well. You can actually see some of the effect of the cilia by seeing the way that some of these bacteria are kind of getting flung around. But if I increase the magnification more, let's see if we can get a little better detail on these guys. I'm going to try to center that. And boost our mag. And I'm still getting that really annoying pattern, but let's see if we can compensate for that. Okay, there. Okay, hello again, Kazer. I see you just joined. Okay, there we go. That goes away a little bit. You need a little more light. Okay, and if we get the focus just right and take a lot of drugs, we might be able to see the beating cilia. This can be pretty subtle. It'll just look like a little flicker, almost like a little flickering flame around the cell body. Okay, I'm still trying to fiddle with the lighting to get as much contrast as I can. And probably making it worse. But if I can focus up and down on one that holds still for a little bit. Yeah, okay, I'm having a hard time spotting the cilia on this particular camera rig. But let me see, this is going to go kind of bad for a bit. But I'm looking through the other eyepiece with my own eye. And yeah, I can actually see the cilia just a little bit better here, just a kind of little flickering sheen around the individual cells. So I'm just going to go back on medium power and twiddle the lighting again to try to get rid of that background pattern. There. Okay, so It's hard to spot, but they are in fact covered in cilia. It looks like we've got two species now. We've got several that are kind of rounded on both ends, but there's one right here that's kind of in the middle that's actually got kind of a squared off appearance on one side, and I'm seeing him right up there at about my 10 o'clock. There, I've got him centered right there. Do you see that the front end is kind of squared off? Maybe a little rounded, but not tapered the way it is with the others. If I could get him to slow down a little bit, he almost looks like he might have specialized cilia on one end. It's getting hard enough. I think I can see, unless it's the after effects of quitting crystal meth yesterday. Actually, I'm kidding. I think I can almost see that he's got some specialized cilia around one end that are longer than the rest, which means that this guy isn't stentor, but there's a reasonable chance he's close to it. So kind of an oblong shape. Here, I tell you, let me see if I can. Realistically, I probably can't. I was going to try to take a still picture, but how fast this guy's moving, it might just be a blur. Yeah, looking at live ciliates is going to be tricky without a means of slowing them down. And unfortunately, we don't really have that. Yeah, I can't really go around and give you folks dropper bottles of nickel chloride. It's not really practical for more than a few people of you. But there's at least two species of ciliate right here. One that's kind of oval shaped, that if I had to guess, I would say might be genus Certolophosis. And then that squared off one right there that I think has extra long cilia around the head end. And that's the end that he keeps sticking right onto that bit of decaying organic matter, because I assume that's what this one is doing. Organic matter. So there's probably a cell mouth up there at the front end, the end that's closest to the brown blob. And yeah, there we go. So we've got a nice little ciliate community right here. Let's see if we can spot any more. Let's go looking for different species. So there's a bunch right there. And every so often you'll see a few that are just kind of zipping through. Okay, I think that's one of the ones that we've already seen, but it's slowed down enough that maybe we can get a better look. Okay, that really small spiral-looking thing could be one as well. Let's try to zoom in on this one. Yeah, I think that's one of the ones we were already seeing. We were just looking at, I think he's just slowed down a little bit, probably because he's about to die. It happens. Okay, that little spiraling one. Okay, there's another piece of gunk. But I didn't see anything on it. Okay, I think that's the same bunch as where we were. And okay, there's another air bubble right there. You're focused on the film of water, not on your own cover slip or anything like that. I think that's just dirt on top of the cover slip. You are going to want to keep these as clean as you can. Ooh, this is interesting. Okay, let's zoom in on here and see if I can get a shot of her. Okay, there are some ciliates that are grazing. There's one that I'm seeing right now at about the 3 o'clock position, but over at about the 10 o'clock, there's something that's about the size of a ciliate, but it looks like it's got a long tail, and it looks like it's almost got a jointed appearance to the tail. You can see that tail's made up of several joints. That's actually an animal. That's a multicelled critter. It's called a rotifer. We're going to do a later lab that's going to involve getting up close and personal with an awful lot of rotifers. They're about ciliate size, and they tend to live in the same niche. The way you can tell these apart is many of them will have that kind of jointed appearance to them. Ciliates don't really have joints. They'll typically have a tail with 1 or 2 little toes at the end, and sometimes they're very long and sometimes they're stubby. This one's kind of long, kind of a long single pointed toe at the end. And they've got cilia surrounding a mouth, and inside the mouth there's a pair of jaws called trophi that beat back and forth and crush up the food that they take in. So in this particular rotifer, you can actually see kind of towards the head end something that almost looks like a heart. If I can just get it in focus, it just kind of clicking back and forth. Waka, waka, waka. There, okay, Shivam says he sees it. I assume the rest of you do as well. That's the rotifer jaws. That's the trophi kind of embedded in an assembly of muscles collectively called the mastax. And those function as essentially jaws. So if you see something with jaws clicking back and forth, and something where the body looks like it's divided up into joints, almost but not quite like a shrimp or something, it's a rotifer. It's not actually a ciliate. We do have a very ciliates over here. There's one at about the 3 o'clock, and then there's a larger one over there at the 5. And we've got the usual cast of bacteria and maybe very small flagellated protists zipping around. But yeah, there's our rotifer. I want to say genus Lecane, but I'm not a rotifer specialist. Possibly genus Monostyla, but I could be, well, I'm never wrong because I have a PhD, but you know, there's a first time for everything, I suppose. I think Lecane has 2 toes instead of just 1. That's probably genus Monostyla. Okay, so what you guys get to do for this lab is find yourself a body of water that you can visit safely, and of course mask up and do social distancing and all of that. Don't, you know, risk your health or anything. Take a little water sample from it, and you're probably going to want to get down to the water's edge and scoop some off the bottom If there's, dead leaves or other vegetation on it, try to scrape up some of that. If there's algae, try to get some of that with you, with the sample. You don't need any kind of special collecting gear, an old jar or drinking glass, whatever you've got should work just fine. Take it home, make some wet mounts, and look at them under the scope. And you can see lots of things, a lot of protists that may not be ciliates. You can even see small animals. We saw that rotifer. We've got, insect larvae and little crustaceans and things like that. Amoebas are possible, although they take a little patience to notice. Algae are often fascinating and complex. You're free to just look around and just enjoy what you see. I used to do this a lot as a kid. I had a little toy microscope, and I'd go look at pond water and see all kinds of stuff. I was also stuffed into gym lockers a lot when I was a kid, but you're grown-ups. Hopefully that won't happen. And once you've gotten comfortable with it, I want you to try to identify the ciliates, because you can use ciliates as an index of water quality, because there are some species that are happy in water with a lot of organic matter, water with a high degree of what we call saprobicity, which means rotten organic matter in it. There are ciliates that are perfectly happy in places like, sewage outflow. There's some that are perfectly happy in really organic rich environments like the stomachs of a cow. Cows actually have their own set of symbiotic ciliates in their rumen fluid. One of these days I'm going to find a vet and see if I can't get some of that, but I haven't made any contacts yet. But anyway, and there are some ciliates that like it really stinky and really saprobic, and others that are more comfortable with less organic matter. And if you can identify ciliate species and count the number of individuals in a sample, you can actually calculate an index of saprobicity, which means how much rotten organic matter is in the water. So you can use ciliates as a means of trying to assess water quality, and that's what we're going to try to do. I've sent you guys a handout with a key to identifying ciliates. What it doesn't yet have, because I didn't quite finish it in time, are drawings of the actual ciliates, and I promise to assemble those this afternoon and send it out. And sometime this week, when you get the chance, it does not have to be today, go find some fresh water with stuff in it. A farm pond where the manure is washing in will probably have very high saprobicity. They'll probably be less in a clear stream, but just find something nearby. It could be, the ditch outside your house. Could be one of the creeks in the nature reserve. If you're close to the UCA campus, that should be fairly safe. Find some place with interesting crawly water, take a sample, make some wet mounts, and use the key that I've provided you and the illustrations that I'm going to provide you this afternoon to identify as many ciliates as you can, count them, and then I've got instructions for calculating the water's saprobicity index. So we're going to see if we can use this method of identifying and counting ciliates to try to work out water quality. It would be a lot easier if I could be looking over your shoulders and personally showing you, because I know the ciliates passably well. It'd be easier if I could personally show. But in the words of one of the great poets of our time, this is the world we live in. These are the hands we're given. So stand up and let's start trying to make this a place worth living in, and also a place where we know more about ciliates than we did. Okay, I'm going to go ahead and stop recording now. So we are